Okay, welcome to Lesson 7 in Geometry, Graphing Translations and Reflections. So, transformations are the movement of a shape so that it is in a different position from where it began, but it still has the same size, area, angles, and line lengths. So what that means is the original object and its resulting image after it's moved are exactly the same, and that's considered congruent, so that the angles are all the same, the sides are the same, the points, where the points are is the same, and the only thing that might be different is that it may have a different orientation, and the orientation is how it looks. So if you think of a triangle that's upright with the top point at the top and the two bottom points, and then if you were to turn it so that the longer side was straight up and down and the point was over off to the side, the orientation is different, but it's still a congruent triangle in that everything else remains the same. So there are three different types of transformations that you need to know for this unit. The first one is a translation, which is essentially a slide. So you start with one object here, this lower one, and you slide it up. So you're just changing the x and y coordinates of it, but the actual object itself stays the same. The second one is a reflection, where you're flipping over an axis or you're flipping over a line. So we're going to be mostly concerning ourselves over flipping over the x and y axis, but you have to know how to flip it over another line as well. So if you look at this shape, and then it's flipped over the y axis here, so again, the shapes are still congruent, but the orientation has changed, so the direction that the shape is facing is different. The third one is a rotation, which is essentially a turn around a point. We're not going to spend too much time on that one in this lesson because we will do that in Lesson 8. So translation. So in geometry, a translation simply means that it's moving. So you're not rotating it, you're not resizing it, you're not doing anything to it except moving it to another part on the grid. So to translate a shape, every point on the shape must move in the same direction and for the same amount of distance. So for this one, you have this one sliding over this far and up this far. That means all 3 points need to slide that far and up, that far and up. And in this case, it's 30 units over and 40 units up. Sometimes we just want to write down how the movement is going to go without actually drawing it on the graph. And for that example, again using this example here, you would say that the shape gets moved 30 units in the x direction and 40 units in the y. And so you can write it like this: x plus 30, which means the original x coordinate plus 30 and the original y coordinate plus 40. So essentially that says that all the x and y coordinates will become x plus 30 and y plus 40. The same could be done if you're moving in the negative direction. So if you were going to go to the left, it would be x minus whatever your distance would be, or if you're going to go down, it would be y minus. You could have both. You could have x plus 30 and y minus 10, for example, and be going to the right but down instead of to the right and up. The translation vector gives us details of the translation. So for example, in this example here, each point has been moved 4 units to the right and 2 units up. So the translation vector then is 4 over 2, which is your horizontal step, which is your 4 units to the right. So if we look at point B, we've got 1, 2, 3, 4 units and 2 units up. 1, 2. It's common to label each of the corners of your shape with a capital letter to distinguish your vectors, okay? So when you do the image, the resulting image has a prime mark after it to show the difference between the original object or shape and then the resulting image after the transformation. So reflections are a little bit different, and they are again the flips over a line. So if you take a look at this picture of this mountain, you can clearly see the reflection underneath. And where the mountain meets the water is what we would call our mirror line. So that's where the reflection takes place. So if you notice here, okay, it's the exact same shape, just upside down. So it's been reflected over this mirror line right here. So the image points are the same distance from the mirror line. So this distance from here to this point is the exact same as from here to this point. And the points are always perpendicular, so all of these points are at right angles to your mirror line. So mirror lines can be run in any direction, and this is where I was talking about on the last slide, where most of our reflections are going to happen over the x-axis, which this would be, or the y-axis going this way. But sometimes you might have a line that's going on an angle like this, and your reflecting needs to be at a 90-degree angle to that line. So they can run in any direction. So a line of symmetry is something that we looked at a little bit in the last class when you guys made that 16-sided shape. It asked you to describe that shape, and that particular shape was again a 16-sided shape, but it also had 4 lines of symmetry. So a line of symmetry is being able to fold a shape on a line that is so that exactly half the figure matches the other half. So a square is a good one. You can fold it directly down the center by perpendicularly bisecting the square, and this half of the square is exactly the same as this half of the square. The same can be said for this half of the square being the same for this half of the square, this half of the square being the same as this half of the square, and this part of the square is being the same. Okay, so a square then has 4 complete lines of symmetry. So how to graph a reflection. So the first thing you want to do is measure the point to the mirror line. So remember that your mirror line for most cases is going to be your x or y axis. So if this is your y axis here, you would measure from your point to your y axis. So in this case it's 1, 2, 3 units away, and this one is 1 unit away, and this one is 1, 2, 3, 4, 5, 6 units away. So then what you do is you go to the other side of the mirror line and you go exactly that far for each point, and then you can connect them again and you end up with a new image. So again, our original object or shape is labeled A, B, C, and the resulting reflection is labeled A prime, B prime, and C prime. So you can also fold paper along the mirror line and then trace the reflection on the image. It's not as accurate because you may not get your fold directly on the line, but sometimes if you've got a wonky mirror line that goes through the center of a quadrant, maybe then paper folding might be your best option. So, but there's a couple tricks to remember when you're going over the axes themselves. If you're going over the x-axis, so if you're flipping from here over the x-axis to here, all you really have to do is take your original point, which was -1, 7, and then change your y-coordinate to the opposite side. So this particular set of points would become -1, -7, which you can see down here. This set of points, -2, 2, would become -2, -2. This one, 6, 5, would be 6, -5, which you can see down here. The opposite is true if you come to the y-axis. When you're looking at the y-axis and you're flipping over here, your y-coordinates are staying the same, but your x is being swapped. So you're now going to a -2, a -10, and a -3 because you're going flipping over this y-axis into the negative side of x. The same can be said here. Your x-axis, your x-coordinates are all staying the same, but you're going from the positive y to the negative y down here. If this was the original image, you would do the exact same thing. You would just go from -2 to 2 because you would going from the negative y coordinates into the positive y coordinates. So I'm going to show you one here. So this is essentially our original image. So if we were to reflect this image over the y-axis here, so we have A at -3 and 7, so you'd have 3 and 7. Because we're switching over y, our x coordinate becomes opposite. We could also just count. 1, 2, 3, here's our mirror line. 1, 2, 3, here's our new point. Same with B, C, and D. Okay. Create our shape, put our points in. So that's reflecting over y. If we were to reflect over x, so if you were to take these points here and we're flipping over x, which means we take the opposite of y, so -3, 7 becomes -3, -7. -6, 7 becomes -6, -7. So you already know where the points need to go just by using that trick rather than having to count them out. So if we were to plot those down here and we already know what they're going to be, and then we can add our points after. So if this was, if we had moved or reflected over y and then reflected from here over x, these primes would have 2 dashes on them instead of just 1, because it would be the second transformation from the original object. So take some time to look at this, and we will do some in class.